Hi everyone, I'm Sanya and I'm going over question 3 from week 7, which is on trees. This question is asking us to write a function that will return true if and only if there exists a path from root to leaf that contains at least n instances of element in a tree T. So before we get going on this question, I wanted to go over some tree basics, and I wanted to construct this tree together. So we're going to call it tree. And the first node is going to be the root node, which is this. So that's going to be 1. And then after we are going to make the branches. And the branches are a list of trees themselves, which means we have a list of trees. So let's first construct this one. So the first 2. And then once again, 2 has branches. So we are going to have to make a list of branches, a list of trees. So this node does not have any branches. So we can, and right here, same for 5 and 6. And we finished this first part. Now let's move on to this. So this is going to be, and then this also has branches. And now we finish creating all the trees that make up the branches of the tree that starts at node 1. So we finished making this tree, and I wanted to color code this a little just so it's a little clearer. So we start at 1 and we can see that this is right here. And then what's remaining is all of the leaf nodes. And what's unique about these is that they do not have the list of branches. Instead, what is implicitly passed in is just an empty list. So calling tree 4 is equal to calling, these are the same thing. And we can see here that trees are a really good data structure to recurse over because as you iterate through the branches, you're iterating through more trees. And then an obvious base case is when we reach a leaf node. That is the most common and the most obvious base case to use when dealing with trees. Okay. Let's start looking at the doc tests a little bit now. So they make a tree T1, which has a root node of 1, and then a branch to another node of 1, and then another branch to 2. And one thing to note here is that every time you call tree, you're basically creating another branch. We can see that here too. This branch is this tree. This branch is this tree. And then these are these. And this branch is this. Let's go back to the doc tests. This line here is asking us, does the tree T1 contain at least 2 times in between a path from the root to the leaf? And the answer is yes. We can see that there is a path that takes us from the root to the leaf that contains 1 twice. And then this is asking us, does the tree T1 contain 2 twice in a path from the root from a root to a leaf? And the answer is, the answer is for this one, the answer is no. We can see that there's only 1, 2 from all paths from roots to leaves. And then the last doc test is asking us if T1 contains the element 2 at least once in a path from a root to the leaf. And we can see that it does right here. and that it is at a leaf node. So that's just something to keep in our, that's a case that can happen, that we can see the element at our very last node. So now let's start going through the code itself. So if n equals 0, we return true. And let's think about what that's saying. If we can iterate through, when n is 0, this is basically telling us that does T contain the element lm 0 times in between the root to a leaf. And we know that this is always going to be true. It is always going to contain element 0 at least 0 times. So that makes sense. And then for the next base case, we can look at if we're at a leaf node, which is a very common thing to do with trees. So if we are at a leaf node, we need to, and we know that n is greater than 0. The only way that we could return true here is if n is 1 and we are at a node, at a leaf that equals element. Because if n is greater than 1, we are not going to see element n times by the time we reach a leaf node, because we are at a leaf node. So if n equals 1, and the second criteria was that we are at a node that equals element. So, and we can see this clearly, more clear from this, this example, the third one right here. The n does equal 1, and when you reach this leaf node, the label will equal element, which is 2, which is why we return true here. And then if the label of T equals element, and we're not at a leaf node and n does not equal 0. So here we need to iterate through all the branches. So we definitely are going to need to call contains n again. And since we only have one line and want to iterate through a list, we are probably going to need to use a list comprehension. So we can start off with what we know. And we know that we're going to still be looking for element. However, we have seen element at the node we are at. So now we only need to see it n minus 1 more times before we reach a leaf. So that, and then we need to iterate through all the branches of T, which means 4. And this is going to return a list of trues and falses. And we just want to know if at least 1 is true. So if 1 is true. And now the last case is if the label is not equal to element, which means, so if the label is not equal to element, that means we don't decrement n, because we still have to see element n times before we reach a leaf node. And we still need to iterate through all the branches. So that does not change. And then again, this is going to return a list of trues and falses. And we want to see if at least one path returns true. So if at least 1 is true. And that is our function. Thank you guys for watching. I hope this was helpful.